What's up guys, this is Luke Hill for Kit Guru, and these are AMD Ryzen Threadripper processors. AMD is back in the high-end desktop and they're back with a bang. They've done what some of us only a few months ago would have thought unthinkable. They've hit Intel where it really hurts, the high-end desktop consumer market. And if you ask me now, what's the highest performance multi-threaded CPU on the market? Well, that honor goes to AMD's Ryzen Threadripper 1950X. Let that sink in for a moment. AMD is offering the fastest processor on the consumer market. So the specs of both of these processors are known by now. The 1950X is AMD's brand new Ryzen Threadripper flagship. So that's 16 cores, 32 threads via simultaneous multi-threading. 3.4 GHz base clock, which goes up to 3.7 GHz on all-core, provided you stay within thermal and TDP limits. Up to 4 cores can boost up to 4.0 GHz using precision boost, and up to 4 cores, which is new, can boost up to 4.2 GHz using XFR, so if you satisfy other conditions such as thermal and power draw. And the 1920X is very similar, except that it offers 12 cores and 24 threads instead of the 16 cores and the 32 threads from the 1950X. It also bumps up the base clock very slightly from 3.4 GHz to 3.5 GHz. So TDPs for these 12 and 16 core beasts are set at 180 watts, and don't confuse that with power consumption. TDP is only loosely related to power consumption, so basically what that means is you need 180 watts worth of cooling capacity to allow these chips to operate at their rated frequencies. So of course, one of the other big points is the 64 PCIe Gen 3 lanes. Now 60 of these are available for general purpose usage, and you can use up to 7 devices by default. So for example, maybe 4 graphics cards in either by 8 or by 16 configurations, obviously depending on your lane count, and then multiple PCIe NVMe SSDs. So as long as you have less than 7 devices, totaling 60 PCIe Gen 3 lanes or less, you can use that with Threadripper. And that is significantly higher than what Intel offers with its competing X299 platform, which top out as 44 Gen 3 lanes direct from the CPU, and sometimes 28 lanes for the lower cost chips actually, or even 16 lanes if you're talking about Kaby Lake X, but let's not talk about Kaby Lake X. Now there's been a lot of talk about PCIe lanes and PCIe compatibility and capability, quite frankly, being one of the strong points for Ryzen Threadripper, and I think that is the case. 64 lanes or 60 lanes usable is a very high number, and it's higher than 44. Is 44 enough for most people? Yes. Is 60 lanes too much for most people? Yes. Is 44 lanes enough for everybody? No. Is 60 lanes enough for everybody? No, but it's closer and it's better than 44 lanes. I'd rather have too many lanes than not enough, and I think a lot of people who have really high demanding workloads and need multiple expansion cards and multiple fast PCIe based storage devices, I think they would agree with that sentiment. So we already talked about the new TR4 socket, and these are the new X399 based motherboards that AMD will be using as part of the X399, of course, and the Ryzen Threadripper platform. So these are completely incompatible with current Ryzen chips, which use the AM4 pin socket, or the reception socket, whereas obviously Threadripper is using a pad type system on the CPU, as we see with Intel, and then an LGA socket with pins based inside it. So let's talk performance, and I will warn you that I'm not going to sit here and go through every single performance figure. I'm just going to give a brief overview. If you want to see the performance and the charts, I do encourage that you go and read the full article on kitguru.net on the website, so you can read it at your own pace in written form. But starting with everybody's favorite, Cinebench and the multi-threaded test. So, and of course I got my cheat sheet here. So Cinebench multi-threaded test, 1950X at stock, 2,985 points. Yeah, that's right, almost 3,000 points at stock from the AMD Ryzen Threadripper 1950X, the 16-core beast. That's pretty incredible. There's absolutely no denying that. The 7900X was impressive when it went past 2,200 at stock. This thing is almost 3,000, and that is 37% faster than the 7900X. Overclocked to 4 GHz, because we did manage to get the 1920X to 4 GHz, and actually the Threadripper 1950X would hit 4 GHz, but it wouldn't maintain full stability that we were happy with, so we backed down to 3.95 GHz, and again, this is all in the review. So 3.95 GHz overclock on the 1950X, 4 GHz overclock on the 1920X. So with the 1950X overclocked, we managed 3,415 points, which was 39% faster than the 7900X, which was also overclocked at 4.6 GHz. So very, very impressive performance to start with in Cinebench. And the 1920X was also very, very impressive in Cinebench. So 2452 points at stock, which is 13% faster than a 7900X at stock, and actually the same performance as a 7900X at 4.6 gigahertz. And with the 1920X overclocked at 4 gigahertz, 2635 points, which is 8% faster than the overclocked 7900X. So multi-threaded rendering performance as shown by Cinebench, absolutely, definitely the domain of Threadripper. That's where these CPUs really perform very well, support the 12 core and the 16 core. So handbrake, so converting high bitrate 4K contents, perhaps you're backing up your Blu-rays or any other high definition, high bitrate media files you create with your GoPro or whatever. The 1920X performed very, very good in here. The OC performance of the 1920X was comparable to the overclock performance of the 7900X, despite its frequency deficit for the AMD chip. That's impressive because the 1920X is actually cheaper than the 7900X. That's a good result. The 1950X, 20% faster than the i9 at stock. Overclock both the chips, and the AMD chip is 14% faster. And the reason these numbers are slimmer than Cinebench is because actually Handbrake couldn't saturate all the performance, all 32 threads of the 1950X. Handbrake is a very, very demanding program, but Threadripper was quite simply, it was just too fast. So we were seeing around about 80% usage in Handbrake, so CPU usage, which leaves about 20% or so usage space. So if you want to go do some photo editing or just even load up quite a low demanding or not particularly CPU demanding game in the background, fine, go ahead, go do it. That's brilliant. Whereas a lot of the other chips, especially the chips sub 10 cores, are absolutely hammered at 100% non-stop when converting high bitrate content in Handbrake. This is actually quite a different one. So X265 or encoding benchmark seems to favor clock speed past a certain point. So the 7900X overclocked was just over 5% faster than the 1950X overclocked. But the 1950X is the fastest stock chip available, and the 1920X is the second fastest stock chip available. And in both of these cases, the frequency wasn't quite high enough to saturate the relative thread counts, so CPU usage sat around about 60 to 75%. But again, that gives you plenty of CPU capacity spare to do other things while you're encoding your X265 video files. So 7-zip performance, put simply, chart topping for the 1950X at stock and OC. The 1920X, again, second fastest stock chip, so AMD scores very, very well in the decompressing test, which is probably what more people do more often than not. So of course you download a zip file or a RAR file and decompress that on your own PC. But of course people who are doing compression or file archival tasks, that's where Intel does particularly well and is even competitive against Threadripper despite its significant performance deficit when we're talking about decompressing. Single-threaded and lightly threaded tests are unsurprisingly not the domain for Ryzen and by extension Ryzen Threadripper. Intel Skylake-based architecture is still as fast as it gets as far as IPC is concerned, and the clock speed advantages for Intel really do tend to favor the Kaby Lake X or the Kaby Lake or the Skylake X chips when it comes to single or lightly threaded tasks. So Cinebench single-threaded result will perfectly epitomize this because the Kaby Lake X and Skylake X chips will all congregate towards the top of the chart. Other lightly threaded tasks, perhaps you've got a game which only use a couple of cores, or maybe even less than a couple of cores, single core, Total War Warhammer for example, they will be better on the Intel chips, and that's just the nature of the beast. The Ryzen Threadripper chips perform very, very well in multi-threaded tasks, and anything that scales with a high core count and a high thread count. The Intel chips are still very, very good in lightly threaded tasks, thanks to their IPC advantage for Skylake specifically, or Kaby Lake, and also because of their frequency advantage in general. So moving on to memory bandwidth, of course, quad channel memory is one of the big points for Ryzen Threadripper, and it was one of the, perhaps in some respects, weaknesses for Ryzen 7. So Ryzen 7 had plenty of cores and particularly good computational power given its price, but it was only dual channel memory. So Threadripper answers that. You've got quad channel memory, and we run G.Skill Triton Z memory, 3200 MHz, CL14, quad channel, absolutely no problems. So none of the memory compatibility limitations that we saw from the beginning with the Ryzen platform, they seem to have been fixed as they are now on AM4. They seem to be no problem from day one with Threadripper, and that performs really, really well. Memory bandwidth was between 62 to 66-ish gigabytes per second versus Intel's roughly 60 gigabytes per second. So Threadripper actually has, where Intel does well compared to AMD is memory latency performance. However, AMD has tried to address this with its memory mode, different options available in Ryzen Master software, and these are explained in the article, so I encourage you again to go read the article. Another memory point which is important for Threadripper is actually the CPU support up to 2 terabytes. 2 terabytes of memory. So of course you can have to use specialized ECC modules and UDIMMs, and which quite frankly aren't currently available, but you can do 512 gigabytes of memory per channel. Yes, that's right, 2 terabytes of memory on a consumer high-end desktop CPU. Will that appeal to most people? No. Will that appeal to many people? Probably not, outside of the server environment, which is of course not what these chips are being sold for. I say designed for because obviously they're similar to EPYC, but not what they're being sold for. However, it's perhaps a cool feature that's worth mentioning. So as we've already alluded to, gaming performance is okay, but it's not great. It's generally behind Intel, and this is the same that we've seen with Ryzen 7 and higher performance chips for Ryzen versus Kaby Lake or Skylake. This is what we've seen from day one. Intel has a frequency advantage at the high-end side of things, especially with the overclockable chips, and Skylake is slightly faster architecture than AMD's Zen-based architecture, so games gravitate towards that higher clock speed and that higher IPC offered by Intel. And of course, there's also the element of software being developed for Intel platforms in recent years, so Grand Theft Auto is a good example of that, where it just seems to favor Intel hardware no matter what. But if you're only interested in gaming up to 60 FPS, perhaps you've got a nice 4K 60 monitor, Ryzen Threadripper, perfectly fine. Where you will see the performance differences, and this is the same with everything for Ryzen, so Ryzen 5, Ryzen 7, Ryzen Threadripper, is high refresh rate gaming. Intel takes the crown with high refresh rate gaming because the CPUs can offer more performance to the GPU, so they can get those very high frame rates past 100 FPS on average sometimes. However, if you're not interested in high refresh rate gaming and just lock your screen at 60 FPS, Ryzen Threadripper, perfectly fine. Of course, these are by no means gaming chips. However, they might be of interest to somebody who's gaming and streaming at the same time, or somebody who's a prosumer who wants to render their artist images or render their video and then just load up a game while that video is rendering on the background. And of course, the high core counts of these chips, that's their domain. They do very, very well in instances such as that. So I think that covers most of the performance metrics. Let's move on to the power consumption. Now, it's simple. Power consumption is very, very high. And if you thought Skylake X was high, and it is, this is higher. So you're talking at stock for both of these chips, 300 plus watts from the wall using a platinum power supply. That's right, 300 plus watts. So that's more power than the 10-core 7900X at stock on both of these chips. If you want to overclock 4 gigahertz-ish using 1.4 volts, the 1920X, the 12-core, will do more than 400 watts from the wall. The 16-core will do more than 500 watts from the wall. That's right, 500 watts in a Cinebench or Ada64 CPU-only load with the CPU overclocked to 4 gigahertz. If you thought that 650 watt power supply was going to be perfectly fine for a long time, absolutely not. These are going to be up in the power supply requirements for enthusiasts across the globe who want to invest in them. You do need a good quality power supply. You want something with dual power supply connectors, because a lot of these motherboards are using dual 8 pins, perhaps 8 plus 4 pin. They are very, very power hungry. What I will say, however, is the power consumption is largely justified, because if you look in the article, our Cinebench performance per watt chart actually shows that Ryzen Threadripper 1950X is the second best performance per watt in Cinebench CPU that we've tested. So it only lags behind the Ryzen 7 1700, which is a particularly efficient CPU when it comes to performance per watt. And that's really, really impressive actually. So yes, it drinks a lot of power and it commands a lot of power even when overclocked, but the performance efficiency is actually very, very good, so it justifies that power. And the same is true for the 1920X, albeit to a lesser extent because it has fewer cores and Cinebench scales well with multi-threadedness. But the performance efficiency is very, very good. So high power draw, but the performance justifies it. So if time is money to you and you'd rather invest in something that's going to reduce your time and just pay the higher charges on your electricity bill, Ryzen Threadripper seems like a good option in that case, provided you can saturate all of those cores. Now we move on to cooling performance. So of course, with a lot of power being shifted through the chips, you'd be correct to think the temperatures are high, and they are. They're not obscenely high, especially given the power draw, and they're certainly not Skylake X or Kaby Lake X level of poor heat transfer, shall we say, but the temperatures are high. So you're talking with a 360mm Acertec based AIO cooler, so we use the Thermaltake Flow Ring 360 rather than our usual Corsair H110i GT, so the 280mm AIO. So with a 360mm AIO, which is about as good as you can get before going custom liquid cooling, you're talking in the vicinity of 60 degrees at stock on both of these chips actually, and that's in Cinebench Ada64. We don't run Prime, it's just simply too stressful in some respects. Overclock the chips using 1.4 volts, and you're looking at temperatures more in the 70s and 80s degrees range. You have to stay below 85 because that's when you're really pushing on the thermal throttling door because of the offset introduced by AMD. But the temperatures are high, so you're going to need a very, very good cooling solution to be able to maintain temperatures below 85 degrees, say 1.4 volts and 4 gigahertz. If your overclocking target is perhaps 4.1 gigahertz and you want to ramp up the voltage until you get there, you're going to need custom liquid cooling or higher speed fans on your AIO. You're really pushing the limit if you want to go past 1.4 volts and if you want to go past perhaps 4 gigahertz, depending on the silicon lottery. What I will say, however, is that the heat spreader design from AMD, we've already seen that it's soldered and it's very, very good. So you have a large metal heat spreader which works particularly well. Heat doesn't seem to be getting trapped, and actually the 1950X, which was pulling 500 watts or more from the wall, which was largely being driven through the CPU, was actually still running cooler than the i9 7900X, which is pulling around 400 watts from the wall. And that's just a testament to AMD's heat spreader design. There are obviously some exceptions there. We were using a slightly different cooler, as we explained in the article. But again, it's still a testament to the strong design of AMD's heat spreader. So good job there. Look forward to seeing what these things can do on custom liquid cooling, because I think you will be rewarded for custom liquid cooling, because the design suggests that if you can remove the heat, then you can push further. Of course, there's a limit with the actual silicon itself, but temperatures will be lower and frequencies may be able to be higher if you can push the voltage slightly higher. So very impressed by the cooling performance actually. Temperatures are high, but they're not obscenely high and they're not unjustifiably high, especially given the performance and the power consumption. So wrapping things up for Ryzen Threadripper, both the 1950X and the 1920X, because they're both very, very competitive chips. The 1950X is the new highest performance multi-threaded CPU on the market, and the 1920X in many respects is the second place actually. So they've knocked Intel off spot 1 and 2, which is impressive to say the least, given AMD's position in the market merely 6 months ago. So, put simply, the concluding points that we will put forward, and I encourage you to go read the review to see more detail, is just simply excellent performance per dollar. So the 1950X is $999 US. The 1920X is $799 US. What will these be in the UK? We don't know at the moment. Probably about £900 for the 1950X and probably about 700 to 725-ish for the 1920X. So superb performance per dollar. The 1950X is basically the same price as the 7900X, and in multi-threaded tasks, it convincingly outperforms it in a number of scenarios. Despite its frequency deficit when overclocked, it still offers absolutely superb performance, which for the price is very, very impressive, quite frankly, compared to what Intel is offering for the price. So superb performance per dollar, superb all-out multi-threaded performance. PCIe 3.0 connectivity is plentiful, which is great for expansion devices. So if you want to add in a couple of GPUs, a bunch of NVMe SSDs, 10 gigabit NIC, a high performance RAID card, you can add all those things without really starting to worry about CPU based lanes becoming the throttle point or having to be divvied up to an extent where SLI or other devices are starting to be disabled. So that's a real positive for Threadripper, especially when you look at the comparison platform from Intel, which is somewhat confused when we're talking about CPU-based PCIe lanes. So the X399 chipset as a whole has a pretty decent feature set, and when you couple in the CPU and the SoC with that, then the platform's actually pretty good. It's pretty feature heavy. Perhaps not as feature heavy as X299 because of things like NVMe RAID support with Intel and more PCIe lanes on the chipset for other peripherals, but it's a very good feature set for the platform as a whole. It's certainly nothing that I would complain about. You get USB, plenty of USB, fast USB ports. You actually get 10 gigabit USB 3.1 Gen 2 native to the chipset. So very, very good platform overall, quite frankly. So there are some areas where Intel still does offer competitive performance against Ryzen Threadripper, and frequency is one of those areas. So the 7900X, provided you can cool it, can comfortably go to 4.5, 4.6 gigahertz when overclocking. These chips, as we saw with Ryzen, are unlikely to go past 4.1, maybe if you're really lucky, 4.2 gigahertz. So Intel still has the frequency advantage. However, having seen the table that Intel put out recently for the 18, 16, 14 and 12 core Skylake X chips, that may not be the case with those higher core count parts, and we may see frequency come more on parity with what AMD is offering, and that will be a really interesting state for the market, because if AMD is slightly faster with frequency on something like the 1950X, so it can make up for its core count deficit against the 18 core Intel competitor with a slightly higher frequency, then it'd be very, very interesting to see how the performance compares. And luckily, we don't have to wait too long for that. So by the end of September, we should have a very, very good picture of the high-end desktop market. As it currently stands, AMD has taken back the high-end desktop consumer CPU performance throne from Intel. That's right, AMD is offering you the fastest processor on the planet in the Ryzen Threadripper 1950X. $999 gets you one of these chips. You can't go any faster if you've got multi-threaded workloads. It's as simple as that. So good job, AMD. Very well done. Well done. It's great to see competition back in the market. So the onus is on you now, Intel. How are you going to compete? So I'm Luke Hill for Kit Guru. Thanks for watching this video. I hope you liked it. If you did, hit like and subscribe. If you disliked it, hit dislike and tell us why. I do encourage you to go and read the full CPU article with all the words and the analysis and the charts over on the kitguru.net website. And also please do leave a comment over there and give us your feedback. So thanks again for watching. I'm Luke Hill for Kit Guru. Until next time, bye.